Hola, hola. Today we are going to be working on word problems. Yeah, your favorite. To be more specific, we are going to be working on mixture problems. Uh, we call these mixture problems because they are problems where I guess we mix some things. Fun problem 1 and 2 are meant to get the ball rolling, and then for the remaining exercises, we will toss in a variable just for kicks. Alright, so fun problem number 1 reads, how many fluid ounces of pure juice are in each container? Oh, I hope it's on the test. It's not. Yeah. So the first container, let me get my writing instruments. So it says 10% cranberry juice. Cool. So yeah, that's like nothing. Okay. So this has 50 fluid ounces, and I want to know how much pure juice is really in here. So pretty much we're gonna take the percent juice, and then we're gonna multiply it by the ounces. I know we're supposed to say fluid ounces, you know, fluid ounces for like liquid, and then like ounces for weight, but I'm lazy, so I'm gonna scratch out the fluid. So if you want to know how much pure juice is in this bad boy, let's take the percent juice. So we have, it's 10%, and then we're going to multiply it by 50 ounces. 10% of 50, I'm not good at math, but I think that gives you 5. But if you don't trust me, then go ahead, I'll write it, the percent as a decimal, multiply it by 50, punch it in, and then they'll give you 5. So the moral of the story is you pay for 50 ounces of liquid, but there's only 5 ounces of juice. The rest is water. You might as well get the water and then squeeze in a cranberry or two. Yeah, cool. All right. So the next one, we have 30% apple juice, so it's a little bit better. You know, we have more juice in there. So we want to know how much pure juice is in this bad boy. So we have percent juice times the ounces, so it's 30%. So we have 30% times 40 ounces. So 4 times 3 is 12. I believe that gives us 12. Let's go ahead, punch it in. 30% is the same as 0.3. And then according to our calculator, that will give us, what did we say again? 12. Okay. So we have 12 fluid ounces in this container. The next one is my kind of juice. Okay, if I want to buy juice, I want it to be juice, not water with a splash of juice. So we have 100% orange juice. So check it out. How much juice is in here? We don't really have to crunch in the numbers, but I'm going to do it for fake extra credit. If I have 50 ounces of liquid and this bad boy is 100% juice, well, guess what? We have 50 ounces of pure juice. But, you know, I'll just put the math for fun. So it's percent juice, so it's 100% times how much we have. So we have 50 ounces. 100% as a decimal is 1, and then we multiply it by 50. So yeah, it's all of it. Cool. All right. Side note, orange juice is not my favorite. It's actually cranberry. All right. Next one is a trick question. We have 100% refreshing water. Okay, 40 ounce. And the question is, how much pure juice is in here? So if I buy some water, I want it to be water, nothing else. How much pure juice is in here? None. So I guess we could just go straight answer and put 0. But again, I want to do the math. Okay, this one's a little bit tricky. So my eyes, because I see the 100%, I'm naturally gradually leaning towards putting 100%. But I want to know how much pure juice is in here. So remember, how do we do it? We take the percent juice, and then we multiply it by the number of ounces. What is the percent juice in water? 0. So it's 0% times 40 ounces. So that gives us a grand total of 0 ounces. I'll put the fluid just because there's a 0 and the O kind of look the same to me. Okay, so the reason why we do these problems is not because it's going to be on the test. I already told you it's not. It's just meant to get the ball rolling. Okay, fun problem number 2. So it says, Panchito has an 8 fluid ounce can of a 25% grape juice and a 6% fluid ounce can of a 50% orange juice. Okay, so we have some, well, it would have been nice if I kept reading the problem, but I get a little bit excited at times. So we have some grape juice. It's 25% juice. And we have 8 fluid ounces. Okay. We also have some orange juice. It's 50% juice, and we have 6 fluid ounces. Okay, yeah, you cannot see that. That's not good. Sorry about that. Technical difficulties. Okay. Cool. So I like to circle things for fun. I'm gonna work on the lighting. Okay. So for the top, Panchito has an 8 fluid ounce can of a 25% grape juice and a 6 fluid ounce can of a 50% orange juice. He discovered today's hottest exotic drink by combining both juices. By combining both cans. How much pure juice is in the mix? Okay. So I'm gonna do pictures. Okay, so first I'm gonna speak to myself. Okay, so what's going on? So we're gonna mix the grape juice, mix grape with my made up abbreviation. Well, I was gonna abbreviate, but I decided not to. Okay, we're gonna mix the grape juice with the orange juice, and that's gonna give us our nice mix. Okay, so the question is, do we have to do a table? No, I mean, if you can just answer arithmetically, go for it, but my mind doesn't work. If you think that I can read this problem and then knock it out right away, that's a lie. Sometimes I just want to show off in front of you, so I'll do it ahead of time. This time I didn't, but if you saw me like live, I will read it a bunch of times. Okay, so we have some grape juice. We're gonna mix it with some orange juice, and that will give us a nice mix. So this is how I do it. This is my can. It looks like a square. Yeah, it's okay. Can plus can equals mix. Okay, what are we mixing? The grape juice, okay, with orange juice. Okay, how much grape juice do I have? We have 8 fluid ounces, so we have 8. I'm just gonna put fluid ounces here. Okay, and then orange juice, we have 6 fluid ounces. Okay, let me just go ahead, complete it. So the question is, how much pure juice is in the mix? You know what, let me just write down these other facts and then we'll do the rest. Okay, grape juice, what percent juice is it? Thank you, 25%. Awesome. I'm just gonna put percent juice. I like to label things. Orange juice, what percent juice is that? 50%. The mix, what percent juice is that? They don't tell us. Okay, cool. So the question is, how much pure juice is in the mix? Well, the question is, how much pure juice do we have in the grape one? So let me just put pure juice in terms of fluid ounces. Okay, so in this case, how much pure juice do we have? It's 25% pure juice, so we're gonna take 25% and multiply it by 8. Okay, with a little math, it's okay, we'll show the work. We have 0.25 times 8, and that will give us 2. Okay, we got 2 fluid ounces of pure juice in the grape. I want to know how much pure juice do we have in the orange. It's 50% juice, so we have 50% of 6 ounces, and that will give us 3. If you want to crunch it in, go for it. So if you saw me having a moment, well, that's because I don't do it like this, but I'm trying to break this down as best as I can. Okay, so we want to know how much pure juice do we have in the mix. The reason why we're going this route is this: we know how much pure juice we have. We know the strength of juice in the grape and orange, but we don't know the strength of juice in the mix. If we knew the strength, then we would just ask ourselves, what's this percent of this many ounces? Well, how many ounces do we have in the mix? So let me bust out my special effects. Okay, this worked out nicely in my head. I didn't practice it before the video. I didn't have time for that. It's like too late at night. Okay, so we have 8 ounces of the grape. Yeah, that's not gonna fit. 1, 2, 3, 4, 5, 6, 7. Pretend that's 8. Okay, I think that's 8. 2, 3, 4, 5, 6, 7. Oh man, I lost another one. 1, 2, 3, 4. I don't know how to count. Yeah. And I'm a teacher. Oh, I'm so embarrassed. Okay, cool. We got 8 of the grape, and then we got 6 of the orange. Is this a good mix? Of course it's not, but these are the only colored discs that I have. Okay, we have 8 of the grape and 6 of the orange. So when I toss these two, we got 8 in one, 6 in the other. That's gonna give us a grand total of 14. Okay, so we're gonna have 14 ounces of liquid in the mix. But the question is, how much pure juice do we have? So check it out. The grape juice is 25%, so 25% of 8 is 2 ounces. Okay, yeah, you cannot see that, that's out of camera. Okay, the orange juice is 50% juice. 50% of 6 is 3 ounces. Okay, what do we do with these cans? We combine them. Okay, so when we toss them together, we have a grand total. If I know how to count, I believe that's 5. Okay, that would give us a grand total of 5. Yeah, so I think I made this unnecessarily longer than I had to. My intentions were good, I promise. So now the question is, what if we didn't want to go this route, with or without the chips? Okay, if you didn't want to go this route because you're a fan of tables, then let's go ahead do it the table route. Okay, give me a sec. Sorry, we had some technical difficulties. All right, so let's do this. So again, to answer the question, well, I never wrote it in a sentence, I just said it verbally. How much pure juice is in the mix? We have 5 ounces. Okay, 5 fluid ounces. Okay, I need to learn how to write better. Okay, we have 5 fluid ounces of pure juice in the mix. Cool. So again, if these boxes didn't work for you with or without the chips, I got your back. So let's go ahead and do with the table. So mixture problem, table or not, we need to have a clear idea of what is it that we're mixing together and what the outcome should look like. Okay, so we're mixing some juices, so this is how I'm gonna do it. I'm gonna do a table with a couple of rows, a row for juice 1, a row for juice 2, and a row for juice 3. Okay, so we have juice 1, and since they tell me what kind of juice it is, I'm just gonna put grape. And while I'm at it, I'll put the strength, 25% juice. So we have juice 1 plus juice 2 equals mix. Okay, juice 2 is the orange, and that's 50% juice. Okay, juice 1 plus juice 2 is the mix. It's like, oh, we said that already. Yeah, but you know what? The more times I say it, I'm hoping it'll stick to you. So we have our rows. Now, what about the columns? So first of all, I'm gonna look at the unit. Okay, are we looking at ounces? You know, ¿cómo se dice? Gallons, liters. Sorry, my Spanish comes out. Okay, we have fluid ounces. So I'm just gonna put fluid ounces. Okay, and then we're gonna put the strength, percent, whatever percent. I'm gonna switch the color because this one's too light. You know, percent juice, percent acid, percent alcohol. We're talking about juice, I'm gonna put percent juice. And then the third column is gonna be the amount of pure whatever you have. Okay, so in this case we're talking about juice, so we're gonna put, you know, amount of pure juice, but I'll put the unit, so I'll just put fluid ounces of pure juice. Do you have to write the word pure? No, that's just how my mind flows. You can just put fluid ounces of juice. Okay, all right, so let's go ahead, put some horizontal lines. I'm not gonna do the third one because it messes with my flow. Now I know that in textbooks, you know, we have a table, we have the vertical lines too, but I rarely put them because they get in my way. Okay, what I'm gonna fill in right now are the percents because we wrote them in parentheses. So grape is 25% juice. You can put it as a decimal, or you can let me see, so you can write it, leave it as a, you can put it, you can write it as a decimal, or you can leave it as a percent. Sorry, things happen in the middle of the night. The second juice, or the orange juice, is 50% juice. Okay, so we are gonna fill in whatever we can, and then we'll use what we have to complete the rest. So how much liquid do I have of the grape? We have 8 ounces, and the orange juice was 6 ounces. Cool. How much pure juice do I have in these first two? So the first one is 25% juice. We could copy our results, or we can show the work. So we put percent times 8, so it'll be 0.25 times 8, and that will give us we said 2. And then the second one, how much pure juice do we have? It's 50% juice, so we have 0.5 times 6 equals 3. For the grand finale, how much pure juice do we have in the mix? So we're just gonna add these two. Last time I checked, 2 plus 3 is 5. Okay, so we have 5 ounces of pure juice in the mix. Okay, I need to get better pens. Let's go ahead, take a pause. Okay guys, so that was a good warm-up. Let's go ahead and knock out our four actual word problems from this unit, and then that'll be our day. Cool. So directions, it says form an equation and solve it to answer the word problems. Write your answers in complete sentences, box your answers, and do not forget to define the variable. Okay, sorry, this light is really bright. Okay, the reason why that disclaimer is given is because you are so smart, and I know you just may want to answer arithmetically or even by inspection, but this is an algebra course, so I would really want to assess you on your algebra skills. So the directions don't say you have to set up a table, you don't have to do a nice little chart, or my little diagram. No matter how you brainstorm, ultimately what I need to see is, did you set up an equation? Did you solve it? And did your answer come from the equation that you just solved? So the answer to all those questions has to be yes. And if not, then it's gonna hurt me, but you cannot get full credit. Okay, so it says how much pure cranberry juice must be mixed with 3 gallons of a 20% apple juice to obtain a 40% cranberry apple juice blend. Something mixed with this to get that, so mixture problem. Okay, so I'm gonna speak to myself. I want to tell myself, okay, we're gonna mix this with this to get that. Okay, so from the top, how much pure cranberry juice? So we have some pure cranberry juice must be mixed with 3 gallons of a 20% apple juice. So we have some apple juice, and we know how much, to obtain a 40% cranberry apple juice blend. So it looks like I highlighted everything, but that's just how I think. I circle things that I find important. Okay, so mixture problem. So I'm gonna say mix the cranberry juice, I'm gonna do my made-up abbreviation, with apple juice to get a nice mix. Okay, cool, fantastic. I'm gonna go ahead and do it with the little box model, and then I will do it again by using a table. Okay, so you do what works for you. So for these mixture problems, I'm gonna do the setup. Box plus box equals mix. Okay, so we have box plus box equals mix. Why do I like squares? Because they're easy for me to write, as simple as that. If you want to do like nice juice bottles, knock yourself out. Okay, so with a little love note, we already said that we're going to mix the cranberry juice with the apple juice. So I'm just going to say the first one is cranberry, the next one is apple, and then we have mix. Okay, we're talking about juices, so below each box I'm going to put the percent juice. Okay, cranberry, it's pure cranberry juice. So what is the strength of pure cranberry juice? It's 100%. Okay, so depending on what we're talking about, pure something could be 100%, or pure something could be 0%. This is why I like to label these things. Apple juice, what's the strength? 20% juice. What's the strength of the mixture? 40%. Okay, the blend. Cool. Now, how much liquid do we have inside? So we have how much pure cranberry juice? No idea. I'm gonna put a question mark. Do we have to do that? No, that's just how I think. Okay, how much pure cranberry juice must be mixed with 3 gallons? I could put the gallon unit below the 3, but those units get in my way, so this is why I'm just gonna put the unit on the side. Okay, how much pure cranberry juice must be mixed with 3 gallons of apple juice to obtain a 40% cranberry apple juice blend? Okay, so wherever I have my question, that's where I have to write it. So how much cranberry juice? No idea, so I'm gonna put X. Okay, now I want to complete the rest of my model. So if I have X gallons here and 3 gallons right here, when we add the two together, X plus 3 will give us X plus 3. Okay, so we have X in one, 3 in the other, add them up, and that'll give you a grand total of X plus 3 gallons in the mix. So right below, we're gonna put how much pure whatever do we have. So I'm just gonna put gallons of pure juice. Okay, gallons of pure juice. So we're gonna do strength times the gallon. So it's 100%. As a decimal, it's 1 times x gallons. How much pure juice do we have in the apple? Is 20% times 3 gallons. How much pure juice do we have in the mix? It's 40% times x plus 3 gallons. Now, what do we know? What do we know about where this number came from? How can we calculate how much pure juice do we have in the mix? So the amount of pure juice from the first container plus the amount of pure juice from the second container should give us the amount of pure juice in the mix. Okay, so that's our equation right there. Let me go ahead and define my variable, where x represents, which is going to put equal sign. X represents, it's in the under the cranberry, gallons of cranberry. So that's it, where x represent gallons of gallons of cranberry juice. Gallons of, just gonna put pure, gallons of pure cranberry juice. Do I really need the word pure? No, because we only have one type of cranberry juice. So I just put that because I'm an overachiever. Okay, so that's our equation. Let's go ahead and solve it. So product of 1 and x is x. Product of 0.2 and 3 is, where am I? 6.6 equals, let's go ahead distribute the 0.4. So that will give us product of 0.4 and x is 0.4x. Product of 0.4 and 3 is 12 1 over, so 1.2. Sorry, that's just how I do my math. Okay, so we have simplified each side. Let's just fix it so the variable terms are on the same side. If I can read your mind, let me go ahead insert my special effect 1, because I really need the 1 for the coefficient. To avoid having negative coefficient, let's go ahead subtract 0.4 from both sides. And last time I checked, $1 minus 40 cents will give us 60 cents. So that will give us 0.6x plus 0.6 is equal to 1.2. Why do I speak in money? Cause I like it. You know, 1 minus 0.4, I don't know. But $1 minus 40 cents, 60 cents. So again, think money. The numbers will just spit out. Alright, let's keep it going. To isolate the variable term, we'll subtract 0.6 from both sides. And that will give us 0.6x is equal to 0.6. Alright, for the grand finale, to isolate the variable term, we'll divide both sides by 0.6. And that will give us x equals 1. Now, when it comes to solving word problems, after I set up the equation, I totally forget what I'm supposed to find because I'm so focused on finding the solution to the equation or solving the equation. So now I'm going to read the problem and then ask myself, well, excuse me, well, what were we asked to find? So the question is, how much pure cranberry juice? Also, how much pure cranberry juice? So according to our little setup and how we defined the variable, we said we needed x gallons of pure cranberry juice. Since x is 1, then we just need 1 gallon of pure cranberry juice. Cool. Okay, so this is the only problem that we are gonna do more than once, because I want to give you, we're not gonna do it a different way. I'm gonna write the same exact thing. The only difference is that I will present it in a slightly different format. And this is the only problem we're gonna do more than once, because if not, this video is gonna be even longer. Okay, so let's do this. So we're gonna pretend that we read this over and over. No, it's okay, let's read it again. How much pure cranberry juice must be mixed with 3 gallons of a 20% apple juice to obtain a 40% cranberry apple juice blend? So we wrote our love note. I'm not going to rewrite that over. Okay, mix cranberry juice with apple juice to get my mix. So let's go ahead do our rows in the table. So I'm going to put juice 1 plus juice 2 equals mix. Okay, juice 1. And if I know what kind of juice it is, because sometimes it just says 10% juice, 20% juice. If I know the type of juice, I'll put the name. So we have pure cranberry juice, and then juice 2, we have apple juice. Okay, apple juice is 20%. Why don't I put the strength on cranberry? Well, because I'm a little bit nervous, so I'm not committed to the percent right now. So when I'm not quite sure, I skip it. Okay, juice 1 plus juice 2 equals mix. Okay, and the mix is 40%. Okay, so let me go ahead and do this. Okay, so for the columns, this is how we're gonna do it. The first one is like the total solution, the next one is the strength, and then the final one is how much pure whatever we have. So the total solution, or in this case juice, the units are in terms of gallons. I'm just gonna put gallons. The next one is gonna be strength, percent, whatever. I really like to write percent something because that's very helpful, especially when it comes to stuff with pure something. We're talking about juice, so we have percent juice, and then we're gonna put gallons of pure juice. Gallons of pure juice. Okay, fantastic. So cranberry, it's pure cranberry juice, so it's 100% juice. Okay, apple juice is 20 and the mix is 40. Okay, sorry about that, but I don't have whiteout. Okay, so let's go ahead, fill in what we can. How much pure cranberry juice? No idea. So question mark. Do you need a question mark? Of course not. You just need a variable, but that's my style. It's like I don't know something, question mark. That way I can see, not just remember, that way I can see what is it that I'm trying to find. How much pure cranberry juice must be mixed with 3 gallons of a 20% apple juice to obtain a 40% cranberry apple juice blend? Okay, I'm gonna put this to the side. Now in this case, we have a table. We already plugged in all the numbers that we could. What we need to do is work some magic to complete the rest of the table, and then we'll take it from there. How much pure cranberry juice? No idea. So I'm just gonna go ahead, call that X. Okay. How many gallons of juice do we have in the mix? Same speech. If you have X in one and 3 on the other, you're gonna add the 2, and X plus 3 will give you X plus 3. So if we have X gallons in one and 3 on the other, when you add the 2, you're gonna have a grand total of X plus 3 gallons in the mix. Now, how much pure juice do we have in each one? The first one is 100% juice, so the decimal equivalent is 1, and then we're gonna multiply it by X gallons. You can simplify this expression now, or you can simplify it later. With your permission, I will do the later. How much pure juice do we have in the second one? It's 20% juice, so 20% times 3 gallons. How much pure juice do we have in the mix? It's 40% juice, so it's 40% times X plus 3 gallons. Now, if you go the table route and you can complete it successfully, then the equation is just screaming to come out. We know how much pure juice we have in the mix, but where did that come from? Well, that came from the amount of pure juice in the first one plus the amount of pure juice in the second one. So this is our equation in disguise. Okay, I forgot to define my variable, so I'm gonna say where X represents, it's in the gallons column for cranberry juice, so same speech, gallons of pure cranberry juice. And I'm going to rewind to my earlier speech. Okay, so there's our equation. The amount of pure juice in the first one, I'm just going to go ahead, I'll put 1x, plus the amount of pure juice in the second one should give you the amount of pure juice in the mix. Okay, so I'm not going to bore you, so I'm just going to, what do they say? With the power of TV, or the magic of TV. Okay, because we already did it. What did we get? Go ahead, look at your notes. We got X equals 1. Okay, so to answer the question was where am I? Okay, the question was how much pure cranberry juice. So we want to know how much pure cranberry juice. We said we needed X gallons. X is 1, so we need 1 gallon of cranberry juice. I don't know how to spell cranberry. Okay. Did I forget the word pure? No, I just omitted it for fun. Okay. Cool. So again, I said we're gonna do a total of 4 word problems. We're not gonna do them twice. Okay. So I myself personally, I don't answer these mixture problems with the table, but since we cannot do each problem more than once, I'm gonna have to stick with one. Some students like it when I do the little box model. Some students like it when I do the table. I'm gonna just flip a coin and go with the table. Okay, let's go ahead, go do it the table route. But you know what? I got a challenge for you, because you know it's all about challenges. You know, not just TikTok and all that good stuff. Okay, so I got a challenge for you. We're gonna go the table route, and then you can do it again by using the box model, and then whatever you feel comfortable with on the quiz or test, that's how I want you to do it. Just make sure you define the variable. Okay, so let's do this. So it says Conchita has 2 solutions available in the lab, one with 10% alcohol and another with 20% alcohol. How much of each should she mix together to make 30 milliliters of a 14% alcohol solution? So something about mix whatever. Okay, so mixture problem. So Conchita has 2 solutions available in the lab, one with 10% alcohol, they don't tell us how much but we know the strength, and another with 20% alcohol. Same speech, they don't tell us how much but we know the strength. And the question is, how much of each should she mix together to make 30 milliliters of a 14% alcohol solution? So box for table, the first thing that I want to do is delineate what am I mixing. So I want to say mix this with this to get that. So mix, what are we mixing? We're mixing the 10% with the 20% to get 30 milliliters of 14%. And the question is, how come I'm not writing a sentence? Because I don't feel like it. If I wanted to write a sentence, I would just write this the prompt. Okay, so we have some alcohols. Alcohol 1 plus alcohol 2 equals mix. Let's go ahead and do some rows. So we have alcohol 1, that will be our 10%, and then we have alcohol 2, 20%. Okay, and then we have alcohol 3, but we're gonna call it our mix. Okay, mix is 14%. Okay, and then for our column headers, they're always gonna be the same. The units may change, the wording may change, but the train of thought is the same. So the first one is like the total volume. If we're looking at liquid, you know, total volume. The next one is the strength, so percent, in this case percent alcohol, and the third one is how much pure alcohol we have. So total, percent, pure. Okay, so we have the units are I guess milliliters. Okay, and then the next one is the strength, percent alcohol, and then the next one is how much pure whatever we have, so milliliters of pure alcohol. All right, fantastic. Okay, let's go ahead, plug in what we know, and if you put the strengths in parentheses, you can do that right now. So we have 10%, 20%, and the mix is 14%. Okay, I saw 30 somewhere, and that's associated with the mix. Okay, so all the numbers from the prompt have been given, so we just need to write expressions for whatever we can, and then use our imagination to complete the rest of the table. Okay, so from the top, actually I'll go to the punchline. How much of each should she mix together to make 30 milliliters of a 14% alcohol solution? So the problem that we did before, we were just missing like one. Okay, in this case we're missing both, so I'm gonna put question marks on both. How much of each should we mix together to make 30 milliliters in the mix? No idea. We can do this with 1 or 2 variables. We're gonna do this one with 1, and then if you want we could do it later after a couple of chapters, we'll do it with 2. Where should you put the x? To tell the truth, it doesn't matter. But for me, if both of them are unknown, I just put it on the top because it's aesthetically pleasing. Okay, let me go ahead define the variable right now. So I'm gonna say where x represents, you know, I write the equal sign in in lieu of the word represents, but go ahead, write the word represents. Where x represents milliliters of something. Okay, where x represents milliliters of a 10% alcohol solution. So milliliters of a 10% alcohol solution. Fantastic. Okay, now this is where it's a little bit tougher for me to digest. Okay, so let's go ahead and do this. I think I got the wrong problem. Yeah, I wasn't gonna do this one next, but it is what it is. Okay, so we know that when we add these two, that should give us a grand total of 30 milliliters. So the sum is 30. If we have x in one, to see how much we have in the other, we're gonna go ahead take the difference. I'm gonna put it to you like this. Let's just say we had 2 milliliters in the first one. If the total is 30, if we have 2 in one, I know you're a genius. You're like, we have to have 28 in the other. But your preschool friend asks you why. And you're like, oh, because I gotta subtract. I gotta do 30 minus 2 to make 28. Well, I need you to use that same train of thought. The sum is 30. Okay, x plus something equals 30. If you have x in one, to see how much you have in the other, you're gonna take the difference. 30 minus x. And if you're iffy on it, like if you're like, I don't know if it's 30 minus x or x minus 30, okay, you can just add them up. X plus 30 minus x, x minus x cancels, and that gives us 30. So the sum checks out. All right, moving forward. Let's go ahead complete the rest of the table. So what we're missing are expressions for how much pure alcohol do we have in each item. So the first one is 10% alcohol. The next one is 20% alcohol. And the next one is 14% alcohol. All right, give me a moment. All right, so let's go ahead and do this. So the table is completed. So how is it gonna go down? If you're going the table route and you're able to successfully complete the table, then that's it. The equation is just going to come out. So pretty much we know how much pure alcohol is in the mix, but the question, where did that number come from? So we're gonna take the amount of pure alcohol in the first one, add to it the amount of pure alcohol in the second one, and that should give us the amount of pure alcohol in the mix. So again, our equation is just there. Let's go ahead and write it out. So the amount of pure alcohol in the first one plus the amount of pure alcohol in the second one should give us the amount of pure alcohol in the mix. Cool, so let's go ahead, use our calculator, punch it in, or freehand it. When we distribute the 0.2, that should give us 0.2 times 30. Go ahead, punch it in for me, gives us 6. 0.2 times x will give us 0.2x. Let's go ahead, put a 0 in front along with the minus. 0.14 times 30. I'm not going to pretend like I did it in my head. You know, I used a calculator. Let's take our time, combine the like terms. If you feel comfortable to combine them right now, go for it. If you're like me, it's like, I'm just going to write them side by side, then go ahead, write them side by side. So we have 0.1x minus 0.2x, and then we'll bring down the constant term, equals 4.2. So again, you don't have to put them side by side, but this kind of helps. If I'm freehanding it, it helps me a lot. 10 cents minus 20 cents, I owe someone 10 cents. So like in English, negative 0.1x, we bring down the rest of the problem. Work your magic. Let's go ahead, isolate that variable term. We'll subtract 6 from both sides. And last time I checked, 4.2 minus 6 will give us, I should be able to do that in my head. Let's go ahead, punch it in. something with 0.8. It'll give us 1.8 but negative. Okay, we take our time to finish it off to isolate that the variable. Let's divide both sides by negative 1/10, and then that should give us 18. So it's the same speech as before. When I solve word problems or application problems, you know, we grind it until we get that equation. At this point, my focus shifts to solving it. Once we solve the equation, then I'll ask myself, okay, well, what was it that we were trying to find? Okay, so the question says, how much of each should we mix together? You know, so we need I was trying to project everything, but I can't. Okay, so I'll do it like this. For the 10% alcohol, we needed X milliliters. Okay, for the 20% alcohol, we needed 30 minus X milliliters. Okay, so that came from our table, which unfortunately I cannot project. Okay, so for the 10% alcohol, we needed X milliliters, and the 20% alcohol, we needed 30 minus X milliliters. So if X is 18, we need 18 milliliters of the 10%, and 30 minus 18, or 12 milliliters of the 20%. Okay, so I think we were asked to write it in a sentence. So how much of each should she mix? She should mix 18 milliliters of a 10% alcohol with 12 milliliters of a 20% alcohol. Period. Fantastic. Okay, so I said we were gonna do a total of 4 problems. If you're like, that's it, I'm done, then go for it. Okay, but if you want to stick around, let's do this. If you want to like leave and come back, I'm okay. My feelings will not be hurt. Okay, so let me go ahead, find the next problem. Okay, so our third and almost final mixture problem. So it says Panchito has a 10% alcohol solution and a pure alcohol solution. How much of each should he mix together to make 7.5 liters of a 40% alcohol solution? So something about mixed together, so mixture problem. So no matter what we're mixing, alcohol, juice, acid, you need to delineate. I'm taking this, mixing it with this to get that. Okay, so Panchito has a 10% alcohol solution. Well, that's nice. And a pure alcohol solution. Okay, how much of each should he mix together to make 7.5 liters of a 40% alcohol solution? So this is how it's gonna go down. We're gonna take the 10%, mix it with the pure alcohol, and the outcome will be a 40% alcohol. So I'm gonna say mix the 10% with the pure alcohol, and that will give us 7.5 liters of a 40% alcohol solution. This brainstorming thing is not needed, but you'd be surprised what a difference it makes for me. If you don't need to brainstorm, I don't need to see it. You don't need a table, I don't need a table. What I do need to see is that equation though, and the variable defined. Okay, let's go ahead and do the table route. First item plus second item equals mix. Okay, so we have alcohol 1, which is 10% alcohol. Alcohol 2, I'm not committed to the strength, so I'll just put pure. Okay, and then alcohol 1 plus alcohol 2 equals our mix, which is 40% alcohol. Okay, our column headers are going to follow the same structure. The words may fluctuate. So the first one is total liquid, so milliliters, gallons, ounces. The next one is strength, percent something, so percent alcohol. And the final column is pure something, so how much pure alcohol do we have? The units are going to be liters Okay, the next one is going to be percent alcohol. And then the next one is going to be liters of pure alcohol. Fantastic. Okay, let's go ahead, fill in the strengths. We have 10% alcohol in the next one. And the first one, sorry. The next one is pure alcohol. So pure alcohol is called for 100%. Okay, and then the mix is 40% alcohol. Okay, I saw 7.5. The 7.5 is associated with the liters of the 40% or the mix. And then the question says, how much of each should he mix together? Okay, so both of these are unknown. So where should we put the variable? You know what? Wherever you want. You want to put it in the bottom? Go for it. But I said before, for me it's just easier to put it in the top one. Why? Because I'm used to it. The more I do things the same, the more it will stick to me. Now, I know that you know that the sum should give you a grand total of 7.5. Okay, so X liters in the first one plus so many liters in the second one, that should give us 7.5. So if the sum is 7.5, to see how much we have in the other one, we're going to go ahead take that difference. So we have 7.5 minus X liters. Let's go ahead, define the variable. So I'm going to say where X represents, it's in the liters column for the 10% alcohol. So we're going to put liters of a 10% alcohol. Liters of a 10% alcohol solution. Fantastic. Alright, let's go ahead complete this table. So how much pure alcohol do we have in each one? The first one is 10% alcohol, so it's 10% times X liters. The next one is 100% alcohol, so it'll be 1 times 7.5 minus X. And the final one is 40% alcohol, so it's going to be 0.4 times 7.5 liters. Okay, so same speech, we know how much pure alcohol is in the mix, but the question is, where did that come from? So the amount of pure alcohol in the first one plus the amount of pure alcohol in the second one should give you the amount of pure alcohol in the mix. Okay, so same speech. The question is, why do I say the same thing? Because it's the truth. Okay, pure alcohol from the first one plus pure, let's go ahead and write it. So the amount of pure alcohol in the first one plus the amount of pure alcohol in the second one should give us a grand total of the amount of pure alcohol in the mix. Cool. Alright, so let's go ahead, simplify. I'm not gonna try to do anything in my head, I'm gonna just punch it in. Okay, so we have 0.1x, distribute the 1. Oh, I'm a genius. So that'll give us plus 7.5 minus x equals 0.4 times 7.5 gives us 3. Okay, I punched it in. Right, let's go ahead, combine the like terms. You guys want to leave, so we're just gonna go straight to answer. Okay, coefficient of the second x is 1, and 10 cents minus $1, we owe someone 90 cents, so that will give us negative 0.9x. We bring down the constant term, plus 7.5 equals 3. Work your magic, isolate the variable term. We'll subtract 7.5 from both sides, and that will give us negative 0.9x is equal to negative 4.5. For the grand finale, I'm crying because we're almost done. Okay, so to finish it off, to isolate the variable term, when we divide both sides by negative 0.9, that will give us x equals 5. And it's like, that's it, we did it. Okay, but if I ask you a question on the street like, hey, how much should she mix together, and then you say, oh, x equals 5, I'll be like, whoa, where did the algebra come from? So let's make sure we answer the question. Okay, so let's do it. So the question is, where were we? How much of each should he mix together? Okay, so according to our table, we need x of the 10% and 7.5x of the pure alcohol. So for the 10% alcohol, we need x, and then the pure alcohol, what was it? 7.5 minus x. Okay, so if we need x of the 10%, then I guess we need 5, what were the units? Liters. Okay, we need 5 liters of the 10% alcohol, and then the pure alcohol 7.5 minus x, so that will give us 2.5. So that's it. So he needs, or is it she? Yeah, he needs 5 liters of a 10% alcohol and 2.5 liters of pure alcohol. So he should mix 5 liters of a 10% alcohol with 2.5 liters of pure alcohol. Fantastic. So I heard it. You like, one more, Miss Torres? It's like, I know, I don't even know what I was gonna say. It's the middle of the night. So one more and that'll be our day. I promise. Okay. So I know that, it's a long day, but you know what? It's okay. After you do your homework, after you take a break, after you do your homework, when it comes to the test, nothing's gonna scare you. Why? Because we will have covered all case scenarios. Okay. So fun problem 6, or 6th and final problem. Cranberry juice is a little too sweet for her taste buds. Whose taste buds? I guess I forgot a word. Okay. How much pure water must be added to 100 fluid ounces of a 30% cranberry juice to reduce it to a 10% juice? Okay, so cranberry is a little too sweet for her taste buds. Oh, I should let it go, but I can't. Okay, so I was gonna put someone. Okay, I guess maybe me. Okay, but that's true. Cranberry is like really sweet for me. I always put water. Okay. How much pure water must be added to 100 fluid ounces of a 30% cranberry juice to reduce it to a 10% juice? Okay, so we're gonna take some pure water. What are we gonna do to it? We're gonna add to it 100 fluid ounces of a 30% cranberry juice. Okay, normally I would have circled the whole thing, but I said a premature pause. Okay. We're gonna take some pure water, add to it 100 fluid ounces of a 30% cranberry juice, and we're gonna reduce it to a percent juice. Okay, so what are we mixing? We're gonna mix the water with 100 fluid ounces of 30% juice. I guess I'll put cranberry juice. We're going to take the water, mix it with 100 fluid ounces of a 30% juice to reduce it to a 10% juice. So water plus juice equals 10% juice. Okay, so let's go ahead and do the table, or whatever, however you want to do it. Okay, so normally I would say juice plus juice equals mix, but we have water, so it'll be water plus juice. What was the strength again? 30%. Water plus juice equals mix. Water plus juice equals mix. Okay. The question is, why don't I do it? Someone told me, how come you don't do straight lines? Because I don't feel like it. Okay. It takes me time to look for my straight edge to do straight lines. This is just to help me to organize these words. Okay. So for the column header, same thing, same speech. Total something, percent, and then pure juice. Okay, so the units are fluid ounces. Okay, so we have fluid ounces, and then percent will be juice, because this one is 30% juice, and then the mix is 10% juice. Sorry about that. Okay, so 30% is associated with percent juice, so that's why it's percent juice. Okay, fluid ounces, percent juice, and then fluid ounces of pure juice. Now, sorry, I don't know how to spell juice. Okay, water, percent juice. We got water. What's the percent juice? 0. Okay, so where's that other problem? I shouldn't have tossed it. Yeah. The problem that we knocked out, we had pure alcohol. We had pure alcohol, and then we put 100%. the reason why we put 100% versus 0 is because this is the percent alcohol. If we're looking at alcohol and it says pure alcohol, then it's 100%. When we wrote pure water, if you want to put pure water to highlight the word pure, my mind wants to say, oh, pure, 100%. But pure does not mean 100%. Okay, depending on what you're talking about, it's either all of it or it doesn't have any. Okay, what's the strength of juice in water? Water doesn't have juice, so it's 0% juice. So I think I made this a little bit longer than needed, but the reason why I say these things over and over again is because I look at student mistakes. So I'm hoping that if I bore you, then you won't do that same mistake. Okay, moving forward, strength of the juice is 30%. Percent juice of the mix is 10%. Okay, and then I saw a number. We have 100 fluid ounces, and that's associated with the 30% juice. Fantastic. Okay, so the question is, how much pure water? Okay, how much water? No idea. Okay, so how much water? We're just gonna say X, and let's go ahead define it right now. So I'm gonna say where X represents unit of this. Okay, where X represents fluid ounces of water. I can just say amount of water and then put the unit in parentheses, but whatever. Let's complete the rest of the table. We got X ounces in one, 100 in the other. When we add the two, we're going to have a total of X plus 100 ounces of liquid in the mix. Now, how much pure juice do we have in each one? Water is 0% juice, so I'm like, what's 0 times X? 0. How much pure juice do we have in the second one? It's 30% juice, so we're going to take 30% and then multiply it by 100. How much pure juice do we have in the mix? It's 10% juice. We're going to take that 10% and multiply it by X plus 100 ounces. And again, if you're going the table route, same speech, okay? If you're going the table route, you got this. The amount of pure juice in water plus the amount of pure juice in the next container should equal the amount of pure juice in the mix. Remind me not to use this highlighter anymore. I always use it, but I'm fighting with the light. Okay. All right. So the amount of pure juice in the water, which is nothing, okay, plus the amount of pure juice in the second container should equal the amount of pure juice in the mix. So let's do this. Product of 0 and X is just 0. 0.3 times 100, that will give us 30. Let's distribute the 0.1 or 10%. 0.1 times X is 0.1X. 0.1 times 100 will give us 10. Okay, we're on it. Again, when it comes to word problem, once we get that equation, it's like a sigh of relief, like, we did it. Okay, keep it cool. We did the equation unit, so I know you got this. Talk to each other. Okay, let's go ahead, isolate that variable term. So we'll subtract 10 from both sides. That will give us 20 is equal to 0.1 times X. For the grand finale, to get rid of the times 0.1, let's go ahead, divide both sides by 0.1, and that will give us X equals 20 with an extra 0, or 200 like normal people speak. That's just how I do math. So the question is, how much pure water do we need? I'm trying to project everything. We need X fluid ounces of the water. Okay, let me go ahead, write it down. So for the water, we need X fluid ounces. Okay, and then X is 200. So we need 200 fluid ounces of water. So I'm just gonna say, 200 fluid ounces of water should be added. Now we don't, I write my sentences how I speak. We don't necessarily speak the same, so I'm not expecting for your sentence to be identical to mine. I'm not even gonna ding you if your grammar is off. Just I grade on effort. Okay, that's it. Okay guys, we did it. This is probably gonna be the longest video. I think for remaining videos I'll cut them into shorter segments. Thanks.